Okay, we are going live. Hello viewers, welcome to Tech Simplified TV and a very warm welcome to the Semiconductor Podcast. We are back with another episode and today our guest has joined us from Bangalore, from his office, Mr. Murugavel Ganesan, Director of Products in SiliconAuto. He has a very illustrious career over 2 decades and today we will learn what is happening in around world, around our country regarding this booming market of automotive vehicles and silicon, that is semiconductor, our industry. So thank you very much, sir, accepting our invitation, and welcome to TSP.
Thank you for having me on your show, Manmohan. Great to be here.
We will start with your story because you have before joining SiliconAuto, you were part of Intel and Infineon, 2 big companies, and how these your previous roles actually shaped up your path for this new job role. How everything came to this place now.
It's pretty interesting. I would say these things started way back. It's even much before Infineon or any other company which I worked recently, right? So I would say my interest in semiconductor electronics started way back. In fact, electronics, I started way back. I remember when I was 13 or 14 years old, when I tried to rip apart my home TV in the house, right? That's how it shaped. But again, my interest in semiconductors and electronics was actually nurtured at home, I would say, and with my dad doing a lot of stuff, DIY stuff at home. But then I got into engineering, did my master's, went to US, and things started to shape up because I think a couple of the companies which I was in the US and even coming back to India, right? I had this glorious opportunity to work on a wide range of products, I would say, starting with wireless and then wireline, IoT, PCI Express, then way back into wireless and to Infineon. So I start with Infineon for now, and Infineon it was a pretty interesting career. I started in wireless domain in 2G, 3G chip design. I was an RTL integration lead. Then I got into some of the central organizations where we supported automotive and other various fields, right, including wireline. So that got into all the complex ASIC and SoC design aspects. That set the foundation. And then before our wireless group got acquired by Intel, I had an opportunity to actually contribute significantly on one of the key automotive chips in Infineon. So that also set the foundation for what I am today, leading products at SiliconAuto, right? And then after the acquisition of a wireless team in Intel, I had this opportunity again to work on a few of the wireless projects again, 4G, 5G domains. I was leading a couple of SoCs as project manager, design lead, and also design manager. Then within Intel, I had the opportunity to work on multiple other various segments, including IoT, wearables, again, networking areas as well. So that's how it shaped. And pretty recently, before I decided to leave, I was in the PSG group, working on FPGAs, right? And this is also a domain where a lot of focus on automotive functional safety, which really got me interested, right? And then came the opportunity to work at SiliconAuto. So that's how my journey started. Pretty happy to be here right now, defining products for SiliconAuto globally. And it's interesting times too, with all what's happening around the world in both EV domain and geopolitics, I would say. Yeah.
Yes. Geopolitics is very much connected with all these things. We cannot skip it. And we like it or not, part of our life. Yeah. So, in your profile, it's mentioned that you were a startup mentor also. So, what career advice? I mean, you usually we see that either people in corporation or in startup. So how you, do it? Being a part of big corporation, advising startups?
Pretty interesting, I would say. So startup and big companies, it's a very contrasting landscapes. So when you are in a large organization, right, like for example, whether it's Intel or Infineon, you have the ecosystem which is well established within the company itself to develop your chips. But in startups, for example, the way I am today and the way we are doing chips, it has to be built grounds up. So there are significant challenges. So in a startup, when you define a product before you go into execution, I think you need to do a lot of groundwork on what you're building, how are you going to differentiate yourself? Because a startup is not going to be easy. It's going to be very cutthroat. And if you ask me personally, automotive is again, it's more niche. Not many players. It's all big players. There are very small number of key startups which are differentiating themselves, but otherwise it's very difficult because in terms of volumes, you need to differentiate yourself where the products are, meaning where the chips are going to get sold. So that way, I think as a startup mentor, I think there are quite a few challenges, I would say. So you need to be very careful about how you're scoping your product. You have to be really careful about your supply chain constraints. You need to differentiate in terms of your product positioning. You need to worry about your industry standards because nothing comes for cheap. So you need to do it in a very nimble way, very cognizant of the fact that they have more headwinds as you go, right? So there are quite a few challenges. So again, the key thing is you need to be very careful in how you're picking, and probably partnerships would help you well when you are actually leading a startup. So that's what I would say is, like, for example, if I have to give an advice to anybody who's actually into startups now, focus on key things where you need to make sure your product is positioned well, you need to strategize well, and have build key partnerships. That is going to help you along the way. Yeah.
Okay. So how do you see semiconductor industry is evolving with Industry 4.0 and AI-driven chip design?
Yeah, so interesting question. So Industry 4.0 is a very generic term, right? So if you look at today, Industry 4.0 is nothing but the fourth industrial revolution, right? The previous ones were mechanization, mechanical engineering, and the steam days, early 1900s. Then came the electrical age. Then came the digitization, right? Very recently. But what's happening today is all big data. So what you do with big data in terms of automation and so forth is what is defining the landscape today. And right in the center of everything is AI. So how semiconductors doing a role play in all of this together is connecting everyday things together, right? So whether it is your home automation, whether it is automotive, whether it is satellites, everywhere you need semiconductors. Even banking, the way it is, where our world is evolving, right? So unlike previous world, right? So I think that today the focus is on, let's say, self-optimized factories, for example. That's another one. So in terms of semiconductors, I think I would say it's AI-driven chip design. I think that's another one, right? Which is enabling this Industry 4.0. And rise of neuromorphic computing, quantum chips. That's another area. And there are also evolving business models around chiplets, because when we were talking about Industry 4.0 for data, you need performance too, right? So your chip architectures don't scale, your process node doesn't scale. So what do you do? There are talks about chiplets and modular design.
Heterojunction integration. Heterogeneous integration,
exactly. Yeah. So all this comes into play, and then you have to really adapt pretty fast to keep up with the market trends. And to meet the scale of compute today, you need to be cutting edge. So again, if you just tie it up with being a startup and trying to do all this is not easy, because then you have to really position yourself between where you actually do the play on the revenue versus your in-feed in terms of money, which comes in. Right, it's going to be a challenge, but just circling back, Industry 4.0 and semiconductors, very interesting times right now, and it's still evolving. So we have to wait and watch how the landscape evolves with the geopolitics also coming center stage.
And what are the biggest challenges in semiconductor product development nowadays, since you are in product development? So
got it. So if you look at the products, if you, again, specifically look at AI versus automotive, these are two completely different domains. So biggest challenge is, if you're a product company, let's say, for example, you're developing AI chips, which the big players are doing. And if you are a small player, you're a non-software player, but you want to play in semiconductors, it's going to be a real challenge because for the kind of compute you need to go for very lower niche nodes, let's say 2 nanometer or 3 nanometer process nodes. And these are not going to be cheap. So again, advanced node complexity also comes into play. That means you need to shell out a lot of money. There's a lot of risks, right? So that is one challenge. Then there is also workforce gaps in terms of people having the skill to actually work on these advanced nodes as well, and trying to bridge the gap between architecture and these areas. So if you look at it on the other side, on automotive, the challenge is very different. From a semiconductor product development point of view, on automotive, we are looking at older nodes, but the focus is on safety, reliability, and quality because you need to sustain for a longer lifetime, right? So if you look at these two different contrasting applications, so on one side, we are talking about AI, high performance, high power. But again, if you're talking about automotive for EVs, you still need to have high performance, but then power also doesn't come for cheap because the way EVs are evolving, you need to think like your mobile phones about 15, 20 years ago, I'd say, where the innovation was about optimizing your battery life, right? It's very similar. So in that scenario, you can still target older nodes, do some architectural optimization and continue. So there is a fine balance on product development. So you need to be cognizant of this fact. And there are also risks associated with supply chain geopolitics. I think you saw during the COVID pandemic time where we had a huge crunch for automotive chips, where the supply was curtailed because of not the very niche, very geopolitical in the sense. You have countries like Taiwan and some foundries in Germany or some foundries in US which are producing but not diversified. So there are challenges even till today, and that's where there are countries banking on setting up fabs and trying to sustain their own supply chains and so forth. Pretty interesting times, I would say. Again, we are waiting for. Yeah.
So, what is SiliconAuto's vision and how it's addressing the evolving need in automotive sector?
Yeah. So SiliconAuto, we are here to solve the biggest automotive engineering challenges. So today, if you'll call it, one of the key challenges is the EEA architecture, the electrical architecture for the car. And if you look at a car which was developed, let's say 15, 20 years ago versus what is getting done today, there's a lot of integration which is happening, and it's getting software defined. That is the key term which we talk about today, software defined vehicles. What it also means is they want to treat cars like a cell phone where you have apps and they want to sell you apps, right? So if you look at this architectural evolution, there are quite a few challenges where there is no standardization in terms of how you integrate the chips together and so forth. So the way the ecosystem is also set up for automotive is actually tiered, right? You have OEMs at the top, you have tier ones and tier twos. The semiconductor player actually comes in as a tier two supplier. And then the tier ones are basically who build the modules together, they validate the software and then give to the OEM. So if you look at all this, if you put all this together, what we are trying to solve today is we are trying to address areas where there is no standardization. We are trying to build chips which are standardized, which will enable OEMs and tier ones integrate their architectures, development in a seamless way. So it will be software defined. So that means you can develop software. You can be rest assured that your architecture will be stay put for next, let's say, 10 to 15 years. And we work with the OEMs, right? And we, as SiliconAuto, we are anyway a joint venture between Foxconn and Stellantis. And Stellantis being one of the largest car OEMs, we work closely with them to define the products on our side. At the same time, we do differentiate and sell the products in the broad market. So again, one of the other key visions also is to be a pioneering force in automotive transformation. So we want to be in the middle, not necessarily to compete with all the big players, but we are here to address key engineering challenges which are about the OEMs. Yeah.
As much I can remember, Stellantis in normal car, not EV, in normal car, the brands like I think Ford and other are connected with these brands.
No, actually, Stellantis has brands like Jeep, Dodge, Citroen. So these are Stellantis brands, yes.
in normal
Yeah.
cars. Now they are moving to EVs.
EVs also, yes, correct.
So, what key semiconductor innovations are driving the rise of EVs and autonomous vehicle? And another curiosity I have, do we really need autonomous car? Why? Is it just a technical uh, advancement, or we need at all? Is there any societal necessity of this thing?
Got it. So, what is driving EVs and the space? So, you want to know specifically about semiconductors for EVs, right? What is driving it?
That
So,
is one. Another one is why autonomous car we are pushing towards it. Autonomous car, do it really necessary to push towards autonomous car? Why we need autonomy in the driving and all? Does
autonomous.
it really?
That's a great question. That's a great question. So, on one side, you are talking about EVs, and on one side we talk about autonomous cars, right? So, again, these are again completely two different landscapes. So,
Okay.
if you look at the Indian ecosystem today, there's not much drive or force behind getting autonomous cars for us, because the focus is mostly on EVs, right?
Hmm.
So we want to get rid of the dependency on fossil fuels. So that's one of the key motivations.
Yes.
And on the EVs also, I think we have big challenges in large Indian cities where we have significant air pollution. And that is also a government-driven initiative to adopt
Hmm.
EVs, right? They have a
Yeah.
goal to get to some level of percentage EV adoption by 2030, 2035 timeframe. And on the other side, we have autonomous cars. But again, if you look at non-Indian market, other places like Europe
Hmm.
and the US or any other places, there is a wide adoption because the ecosystem is also conducive for it in terms of road infrastructure, a lot of other things, right? So, but there's also regulation on safety, which is not as much in India right now. It's slowly evolving, but in other countries, I think it has taken center stage. So then, if you look at it, autonomous driving becomes more interesting if you look at overall safety point of view, right? So you have ADAS different levels, right? Level 2, level 3, level 4, level 5. Level 5 is completely autonomous. So in today's autonomous driving landscape, I think we are at level 2 plus landscape, where your car is able to drive itself with the driver still on the wheel, but you need to be taking control at any given point of time, depending on the situation. But it's changing, right? And there are a lot of regulations in countries like Germany and France and Italy, where there is a minimum requirement to have cars with level 2 plus, which should be fair enough to avoid collisions with um, objects on the road. It could be cars, it could be anything, right? So that's also driving autonomous cars. But in India, I think there are no such regulations yet. The way the government is also seeing is that the market has to evolve by itself. The focus is on mostly EVs, but it will get there soon, right? Once the infrastructure develops. Yeah.
Okay. So, chip design for autonomous, how it differ from other consumer electronics?
Yeah, good question. So for consumer electronics, if you look at semiconductors today, we are focusing mainly on, let's say, low power, high performance. So if you take for example, mobile phones or anything else, right? So if you look at it, there's no safety aspects built in. So if you look at comparison between a regular semiconductors for normal commercial versus automotive. Automotive, the focus is mainly on safety, reliability, and quality also. And you also have a longer lifetime, right? So your chips have to work for 15 years. On the commercial side, I think there's no such requirement. So these are the key driving factors. And then the engineering part of these also are quite challenging, because when you build chips for automotive versus a commercial, in most of the cases, you actually take a commercial design and then port it to automotive and then try to requalify, right? You have to requalify for, let's say, reliability and longer lifetime. I think these are the few examples I can give you. But then the execution time when you actually develop such chips also goes up, approximately by 30 to 40%, because you need to take care of all these regulations and so forth. So if you look at designing chips for cell phone or any other platform, whether you are building chips for CPUs, right? Whether it's data center products versus your automotive, the landscape is quite different. right? I think their focus is on quality. But then there's also legal liability pretty much built into all the functional safety aspects. So it has to work in a specific way. And because of all these reasons, it's going to get, it is quite challenging, right? Building chips for automotive. Yeah.
So, since you are a startup mentor, so what kind of mistake, common mistake you see among the startup founders they make? Common
Right,
mistakes.
right. So underestimating your product, right, in terms of development, right? Development times are pretty challenging. As a startup, as I told you before, the ecosystem which you typically have in a company like Intel or AMD or Infineon or any other large organizations, right? You don't have that ecosystem. So that means there are a couple of things you need to do. You will not be able to uh, scale up in terms of quickly putting up architecture together and execution, right? So you'll have to rely on execution partners. You have to rely on outsourcing. So that is one aspect you need to really care about, because then if you look at the ecosystem, you need to really worry about um, the vendors' expertise in that particular niche domain. Whether, say, for example, if you take automotive, automotive is a niche domain where you need to have skill sets on functional safety and so forth. But in a general semiconductor startup, you need to worry about your foundational IP, whether you're going to buy them, you're going to build them. There are quite a few challenges. You'll have to shell out a lot of money. You need to also look at industry standards and compliance, right? So you need to have to worry about certification and compliance, whether it is you are a large company or a small company, but it's going to pinch you more when you're a startup and trying to address this. And typically, compared to a software startup versus a semiconductor startup, your cycle times are also large. And the cycle times tend to increase if you are in automotive. And the cycle times, till the time you hit the product, is going to be 5 years for automotive. For any commercial product, is roughly about, let's say, 2.5 to 3 years, right? These are the key challenges. But then there are also trying to scale up too fast or too slow, right? You need to really gauge your market. So you need to position yourself in the market, in the competitive landscape, right? And this is where you need to really worry about your innovation and how are you positioning yourself. You need to be really worried about it. And there are startups which are founder driven, and there are startups which are joint ventures. Like, for example, we call ourselves a startup because from an engineering point of view, we have enough challenges and firefights on a day-to-day basis. But then that also makes a difference, your vision, right? And how the path you want to take. And there are things which you need to tackle along the way. And you need to be agile, right? In a startup, things can change drastically. So that is one challenge where, let's say, for example, you try to build an architecture and you figure out that the architecture is not going to scale, and you need to quickly be able to adapt and move into execution, right? That's one. Yeah.
So, if someone is trying to transition into the product leadership role, what should be your advice for them?
Okay, great question. So transitioning into product is good. So, for example, me, if you look at it, I have transitioned from an engineering role into a product role. And so I have this experience firsthand. So there are a couple of things which we need to really look out for. So there are a few key things which defines a product manager, right? A product manager is somebody who has either good business acumen, either a technical strategic, a technical acumen, and there's also strategic thinking. There are a few things needs to come together. There is a good amount of agreement elsewhere in the ecosystem that if you have any of these niche skills, you can be a product manager. So my thought process is slightly different. So if you want to be a product manager, you need to be technically skilled. You need to be able to gauge what the customer is trying to address, what kind of challenges are there. You need to understand them. You need to have a good understanding about the business aspects, and you need to have also a good understanding of the marketplace to position your product, right? So there are technical skills, business communications, you need to bridge them, right? And you need to also learn about pricing strategies, your supply chain constraints, go-to-market dynamics. I think these are a few things you need to understand. You don't necessarily have to tackle technical problems, but you need to understand them and see how to apply it to the product you're trying to define. So at least these are a few key things. But then one of the key areas where product managers play a key role is building a roadmap. Product managers build the roadmap for the company. So you need to be fully aligned with the company's vision. So you need to have a product vision, a product roadmap, and these have to align together because your company's survival, your revenue stream is all dependent on the product you build. So it's very important to define a clean roadmap, which is self-sustaining and is also able to disrupt in whatever product you're trying to enter the market. Right, that's key. So yeah, as a leadership transition, I would say for a technical leader, it'd be very easy. But again, you need to be very careful about the business aspects, right? And you need a good mentor, I would say, when you're transitioning in this role.
Okay. So AI is, I mean, taking part in chip design in semiconductor. How this manufacturing sector, because automotive is not only about semiconductor, it is also about other designing part are there when car design and everything is there. So
Mhm.
AI is involved in that also.
Um, I don't know much about AI in manufacturing of automotive. So the way it works
For
is this, right?
designing part, anything.
So if you ask me about designing semiconductors, yes, there is a lot of AI involved. Right? For example, if you look at most of the Chinese OEMs, what I hear is they have moved from traditional IP sourcing to AI-based in-house IP development. Let's say they want to build IPs in-house. So there is one big OEM in China where it has been called out that they have built everything based on AI, from RTL to GDS, right? So that is the level of expertise they have built. So if you look at automotive, not much from the manufacturing side, I would say, because the way you do it is when you do a car assembly, and when you're talking about semiconductors, the EE architecture, which I called out, is the electronics which goes in, right? The number of semiconductors in a typical car today is more, but the AI part is mostly on how you build the semiconductors. But I'm not very much into exactly if that is really done on the at the car. But again, I know this is how it works on the semiconductor side. Yeah.
Okay. So any upcoming trend that you are really excited about in semiconductor?
Yeah, so very interesting thing is about neuromorphic computing, right? That's one area where you are trying to mimic the brain in terms of performance and efficiency. So there's a lot of research
Hmm.
going on this area. So this is a quite attractive area for me where I've been trying to read up a lot. The next one is quantum computing. Though, let's say because quantum computers, like whether you do a chip, how you do the processing in terms of electrons versus your quantum, in terms of how Google and Microsoft have come up with their quantum chips. At least these are a few areas which is of interest to me. But again, on the automotive side, if you look at it, there are a few semiconductor innovations on silicon carbide and gallium nitride. That is also something very interesting because these two solutions which are coming up in the market today address two key things. One is on the power semiconductor side, and
Hmm.
the second one is on the performance in terms of frequency, agility, right? So I would say all these are very promising today. And in the next, let's say, 4 to 5 years, depending on how the fabs are getting built, how the chips are getting built, it's going to be very interesting. Yes.
Okay. So those who want to join automotive sector, what should be your advice for them? Is there any scope for fresher to join automotive sector?
Yes. So on the automotive, I think there are a few areas, right? If you look at semiconductor, non-semiconductor, there is also embedded, where you do a lot of software development too, right? So it depends on which area you want to target on automotive. Automotive is a very vast area. And if you look at specific to India, if there is a fresher, if they are looking at specific domains where they want to target, we have enough tier one companies in India, like Continental, we have Bosch, we have Valeo, we have Magna, Hyundai Mobis. So all these tier ones, they do assembly and solution development. So what they do is they do embedded, they do integrate chips, they build solutions. and they also target complete software validation. So that means you have an ecosystem built on software. You have also ecosystem which is being built for hardware. So there is a vast domain on the software side. This is what I would recommend. But if you are a semiconductor guy and you are very passionate about doing something on automotive, and there are quite a few innovations which are happening. In fact, SiliconAuto, we are still hiring today. At the same time, there are companies like Infineon, NXP, Renesas, right? There are quite a few in India today where there are quite a few opportunities for automotive, whether it is microcontrollers. We have chips for, we call it autonomous driving. We have SerDes chips. We have infotainment chips. We have ADAS chips. There's a lot of scope. But again, there's enough scope for freshers to target. But then you need to be really aware and target in which area you want to get into, whether it is pure play semiconductors or embedded. Yeah.
Okay. So, what role do you envision India will play in the global semiconductor ecosystem, and especially in automotive sector?
So yeah, interesting time. So you probably heard the recent news about Tesla trying to partner with Tata. We have CG Semi.
I follow your post.
Right. Pretty interesting times. Thanks to our government and leadership. Though late, I think we have come at the right time. And India's first fab is going to come up online next year, which is from Tata Electronics in Dholera. So interesting time because this fab is going to be a 28 nanometer fab, very well positioned for automotive. And as I said before, for automotive, we don't need cutting edge chips right now. And there is a huge volume play for automotive today. And given that the fabs are coming up, we also have OSATs coming up for packaging and testing. This is going to be a very interesting positioning for India in the global semiconductor landscape because there are quite a few players who are lined up. There are also players like ADI. I think you probably saw news sometime back. ADI is also signed up with Tata for manufacturing their chips. So there's quite a volume play coming up. And I'm pretty sure that there will be one or two more fabs which will be coming up in the future once we prove that we are capable, because there's a big, large skill set gap in India in terms of semiconductor operations. But that will get resolved soon with all the government initiatives for skill development and so forth. Yeah.
Okay, so there are some trade restrictions we can see across world. So can we utilize this situation?
Absolutely. So if you look at China, they were in a similar situation many years ago, right? With all the restrictions and let's say IP transfer restrictions and so forth. What they did is they started building things in-house, and today they are self-reliant. I think India also has to go that route eventually, right? The geopolitics will come and hit us. And today, depending on how the geopolitics is played, you are better off if you are self-reliant. I think India is self-reliant on many of the aspects, but on the semiconductor side, I think we are just getting started. I think we are positioned well. And we have the right people, I would say, right? In terms of R&D, I think India has been a powerhouse. We do have a lot of engineers working for a lot of these major MNCs. Like Intel, AMD, NVIDIA, you call them, right? Every company is in India. So I think we have that expertise and skill set. I think we need to start building products. I think that this is where we are lacking. So if you look at the India Semiconductor Mission initiatives also, I think the impetus is on building products in India. I think India has been known for service so far. It's a time right now that we start building products which can really identify India with, right? So that's going to be, that would be the niche, I would say, in the next couple of years.
In recent past, we have achieved self-reliance in making our own vaccine of COVID, and we're making PPA kit in a tough time. We did that as a nation. We have done it. So probably we have to do it in many others. We cannot compare these two, although we have achieved a self-reliance in that sector. Probably we have to achieve it in other sectors also.
Few key points, right? So if you look at the next many years, right? If you look at the impact of the current tariff war, we will see a negative impact probably for the economy in the next year and a half or so. It will have a ripple effect. But at the same time, this is also an opportunity for us to position ourselves for the future, where a lot of big things will surely come, because usually these trade wars and economic downturns, these are all valleys which will come and go, right, very frequently. But again, a smart person will plan and invest for the future. So that way, I would say India's semiconductor ecosystem is positioned well, and we need to plan for the future. But at the same time, as I said, a product mindset will take us a long way while sustaining our service mindset, right? And service mindset, I think we have a lot to offer, but time will tell exactly how the disturbance will come in. But again, I would say India is excellently positioned today. Yeah.
So SiliconAuto has a partnership with other global players also?
Oh, yes, we have partnerships. One key partnership is we have partnered with IMEC, the Automotive Chiplet Alliance program, where we are together with a couple of key players like Tenstorrent, Synopsys. There are quite a few players there who are actually partnering to develop a pretty interesting chiplet strategy for automotive. So I'll talk a few things about it. I think it's going to be very interesting because we talked about Moore's law earlier in this conversation, right? Chips are not scaling in terms of performance, and die size is also growing. So the more the die size, the more the package size also grows, you have yield issues. So one of the ways you can solve it is also by partitioning your chips, right? That is not the only problem. But then let's say, for example, if you have a significant amount of analog integration in the chip, it doesn't make sense because analog doesn't scale as much digital scales. So
Yes.
you are better off on an older node. So all those strategies put together, chiplets will actually help you in a lot of ways, right? For example, Intel and AMD pioneered on the chiplet a couple of years ago, right? I think most of the server chips, if you look at today, even client CPUs, which is on the desktops, they're all chiplet based because it will also help you build products at a faster rate, where you can mix and match different technologies. At the same time, you can actually build any kind of an architecture and scale up. The only aspect you need to worry about is your interconnects, the chiplet interconnects. And you talk about UCIe, which is another open standard, which is pioneered by Intel. And there are a couple of other standards too, like I think there are proprietary standards. There are a few open standards coming up. Like, for example, NVIDIA has NVLink, things like that. But if you look at there are challenges also on that. So very specific to automotive, this Automotive Chiplet Alliance or Automotive Chiplet Program from IMEC is also trying to address for the automotive, because on the automotive side, reliability comes into play. And when you do large chips, it's going to be quality issue, because when you do chiplets, you need to have chips which are still connected. Because of the temperature cycling, they should not break. They should be reliable. So we need to actually research new materials for doing these chiplets. And this is exactly the work which is actually ongoing today as part of the Automotive Chiplet Program. Okay. So there's a lot of good collaboration. But again, standards and materials and so on, there are a lot of aspects to that. Yes.
Yeah.
This is one of the.
So what, as a country, we can learn from Taiwan, Germany, and US with respect to semiconductor, automotive, everything?
Correct. So if you look at these ecosystems, right? So Taiwan is known for TSMC. That's known. Everybody knows. But Taiwan is also known for system builders. They have ODMs like Foxconn, like Wistron. The companies like Foxconn, they make iPhones. So they do devices, right? They are end device manufacturers. So if you look at Germany, they are known for automotive innovation. They are known for quality aspects of that. So if you look at US, I think it's also about innovation, right? US is mainly where the products are defined. So if you look at all these three different ecosystems, there's a quite a number of things you can learn from them. So one is the kind of ecosystem skill set what uh, Taiwan has built, and the kind of products which Germany has built in terms of automotive, even companies like let's say Infineon, and in the European ecosystem you have ST Microelectronics and things like that, right? So that's one, and US. So India can collectively look at all these three together and build an ecosystem of innovation, manufacturing, and overall quality, right? In terms of the products that you want to build. So yeah, there are quite a things to learn. I think we are just getting started, I would say. We have a good foundation. We have a good ecosystem to work with. We need to scale from here. Yeah.
So, what's your vision for India's automotive sector and semiconductor industry by 2035?
Good. So my vision for India's automotive semiconductor industry by 2035 is to focus on making India a global leader in chip design and manufacturing. So today we do a lot of design and manufacturing is done outsourced. There are a very few startups which are actually building, but again, if you look at IITs, I think recently they have built a AI chip, which is pretty much a regular general purpose CPU, things like that. But if you want to look at future, you need to innovate, right? So the innovation comes from a local ecosystem, and that's where having manufacturing supply chain resilience in India helps, and fostering innovation in automotive solutions, right? So there's a lot of impetus coming from the Indian government in terms of PLI schemes and so forth. As long as the government is able to sustain it and we are able to better use those things, it will also strengthen our partnerships in the global semiconductor hubs. Right today, I think India is having a good collaboration with Taiwan, TSMC, which is helping Tata Electronics build a fab, things like that. We need strategic investments in fabs, OSATs, and R&D. Right, I think we have to evolve cities and electronics hubs, I would say, to nurture the talent, and we need to also do a lot of skill building, right? So we have a depth of skills in terms of manufacturing today, but I think with the kind of push from the government, we will be able to sustain it. We'll be able to build and sustain it. Yeah.
I think yes, we need more tech hubs, more,
Yes.
because country it's a vast country with huge population, many so many engineers are there. I think we can support many tech hubs, and that will
Exactly.
be good for the economy also.
We need
So,
a good impetus from the local governments, state governments, I would say,
mm,
to build up the local ecosystem, not just rely
exactly.
on the central government.
Mm,
But there are also need for private and academic partnerships also to do a lot of
mm,
research, because most
yeah.
of the things, we need to publish papers and patents, right? And this is also an area where India can cope. So if you look at the global ecosystem of the number of patents filed, India is still lagging behind. And if you have to compare against China, I think we are not yet there. That also defines exactly how we are positioned for innovation, right? In terms of IPs. Yeah.
Okay, so you have a blog, you maintain it. Tell us about the blog. It's the
Yeah,
digital
that's an
electronics.
interesting journey, right? So it started off in 2004 while I was in the US. And
Okay.
it actually started off as a personal log to actually collect information of, let's say, interview questions to begin with. And then there are also some very basic stuff like logic design, right? Not just interview questions transforming into logic design questions. So I did have a few friends in Israel and US who I partnered with to come up with these logic design questions and so forth. And that's how it started. But then the idea was to educate, inspire, and drive conversations. So that's how it started. So I would say last so many years, more than 20 years right now. And
Mm,
there was a brief lull period where I was too busy with work. But then I started reviving it because I saw there's a lot of readership and viewership where I get a lot of good comments and thanks from a lot of readers. So that actually motivated me.
yeah.
So it revived. So hopefully people like reading it, and if they have any suggestions or asks or requests, they can let me know. Yeah, so
Yeah,
that's
good.
blog has been also my passion, right? So this, it actually helps me also learn about a topic, research, and then write. So that also has a platform for me to learn. So that was also one of the motivations. Yeah.
It's quite interesting blog. I have gone through
Thank you.
it.
Thank you.
And how you manage time between blogging and leadership role? How you manage time?
Good question. So yeah, people do ask me, when do you blog? Is it during the office hours, during evening times, during the weekends? So what I do is I do a mix of weekend, late evening, or early morning. So I'm an early riser. So I'm fresh with
Okay.
ideas when I wake up in the morning. So that's also the time when I focus. So before 6:30, I do get all my ideas for my blog. But I also schedule some of these blog posts. So when I find time, I write a few articles. I schedule them so that they don't come together, but they are sustained in a way the readers are also get a pace, right? That's one. But how I manage time, right? My office work is also pretty demanding
Yeah.
as a product leadership role. I do a lot of customer calls, so I do travel a lot. This also means that I have to work with my local leadership, with the execution teams, with our executive leadership, whether it is CEO, our marketing leads, and things like that. It's quite challenging. But then it's always the balance of time, right? So I believe as long as you prioritize and you manage your work, you always will find time, right? This is this is how I tell people, youngsters, right? So please don't tell that you're busy, right? If you want to make time, you always will make time. And there are times when you get bogged down because of stress, but then writing blogs, that is for me a comfort zone, I would say, right? That gives me a lot of comfort, where you actually research a new topic and come up and write, and then people thank you, right? So yeah, you have to prioritize if you want to achieve something. So that's the yeah.
So, what's your opinion on the way we are developing skilled workforce in India right now? Do you think it's going in the right direction, or we need to do something more? Do you have any suggestion to share?
Yeah, so that's an interesting question. So I've been observing this area for quite a while. Skill development, right? For example, as a product guy, today, if I want to hire somebody skilled, though we have so many job opportunities, it's really hard to get the right skilled person. That could also be because that the curriculum could be outdated in our engineering academia. Because if you look at it, there are IITs and NITs, but then there are all the non IIT, NIT colleges and universities also. There are deemed universities. There is a need to homogenize the curriculum to begin with. This
Hmm.
is the first, right? Where you need to adapt. So if you look at today, the AI landscape is very fast paced. You don't know where to focus, right? What in AI to learn if you are a semiconductor guy. But the general gyan everybody would give you is, yeah, just go take the fundamentals, right? Learn about LLMs, learn about agentic AI, what is evolving. But then folks are also confused, so they need guidance. So the first thing that can come up with is through the colleges and the curriculum. So you need to adapt. I think this is a good time to adapt and make it agile in terms of AI learning. That's one. The second one is we need to have specific skill development areas coming from the government, both federal government, our central government, and then our local leadership. We need to sustain, and there could be areas where you can actually focus on kids, STEM coaching. Kids are also watching everything what's happening on semiconductors and electronics. So that is another area where you can motivate, right? STEM education in terms of science, technology, math, right? So, for example, if you look at kids today, they do read a lot about software coding. Schools actually focus on a lot of coding,
Hmm.
but I would suggest you better start focusing on some aspects of AI, teaching them what AI is and so forth, because the future is going to be defined by AI in whatever you do, right? Coding may not be so attractive because there will be agents coding for you. But then how you differentiate is how you come up with the product mindset. Because me being a product guy, always think products, right? You always need to differentiate. Um, you can always do something where if somebody gives you a specification, you can always go design, do a microarchitecture, you do figure out what to do. But defining a product will differentiate yourself because AI will not come and help there. That is an area you can build, and that is the competitiveness you will build, and everything else AI can handle, right? So you need to understand where AI can help, where it cannot, and focus on those areas because tomorrow the kind of jobs we have today may not even exist, right?
Mm.
So that's that's something I would call out for people. But again, the impetus should come from the broader ecosystem, whether it is government, a public-private partnership, everywhere, right? There should be a cohesive strategy to build skills, I would say. Yeah.
In US and China, they are introducing these deep techs in their school curriculum. So
Right.
we said, I mean, within few years we have to move in that direction too, because when those students complete their school and enter the college or university or engineering college, they have some idea about this deep tech and everything. So things are changing so fast.
Exactly.
Students must
So,
have a little
correct.
bit
So,
idea about all of these things.
exactly. I think there are quite a few AI applications will come into play, right? Whether it is your autonomous driving, right? AI is already there, where it'll make the decisions for you based on the data it collects. The second one is robotics. Autonomous robots are already game right now in China, and you see everywhere. Even Tesla has a robot which is going to go mainstream. My prediction is the next 10 years, many households, whether it is India, it could be anywhere, robots will be mainstream. So that's one area where AI will play. But then there's also risks about security in terms of what kind of role they'll play in terms of safety also. But then there's a regulation needed. But otherwise, there's a lot of scope, whether it is robotics, autonomous driving, in terms of how you develop your products, how you code, how do you do your day-to-day stuff. It's going to be pretty interesting. Yeah.
We are going to move into an age of sci-fi movie. Our regular
Exactly.
life will become like that. These robots are moving beside superhero we used to watch in cartoon animation. Now
Exactly.
that will become part of our life. So
It's
finally,
also
what's
kind of hard to predict also, right, what the future holds. But again, you can make your guesses based on how things are. But AI will also change things quite fast. So before you even realize something new might come up, mainly driven by
mm,
AI. We have to keep a watch.
so? What advice would you offer to aspiring engineers, those who are
Great
entering?
question. Yeah. So yeah, focus on your passion. Just see what your passion is. Don't go by what others are telling you to do. Just see what your passion is. If your passion is semiconductors, keep a watch on the landscape, how things are evolving. Build your skills, right? Be agile. Be very receptive to skill development. The age of software when people used to say, okay, you learn SAP today, SAP may not exist tomorrow, but you learn something today, it may not exist tomorrow. That's a few of the examples. Um, AI in semiconductors is also something similar because it's going to automate a lot of stuff for you, whether it is chip design, how you write your architecture, and so forth. So, my recommendation to everybody who's coming into this arena is be passionate, build your skills, have a mentor who can guide you, and just chug along the way. That's it.
Great. So these were all. I have planned these questions for you. You have anything to share with the audience?
Yeah, quite a few. So I would
Sure.
focus on I would focus on the evolving landscape in India. Right, we were talking about the fabs which are coming up, the OSATs which are coming up. There could also be partnerships because of the trade landscape which is currently happening. So what I would say is it's a very golden time for India in general in terms of how things are going to change. There is going to be a lot of investments coming into India because of specific reasons around between US, China, and the other rest of the domains. But for India specific, I think it's going to be pretty interesting times ahead. So what I would tell people is, I think specifically, I think continuing my conversation, what I was telling before, look out for key changes in terms of the landscape, whether it is semiconductors, whether it is the kind of products which are going to build, but also I would say, yeah. So it's a semiconductor is a pretty interesting thing because it's new in India in terms of manufacturing. But again, the skills around semiconductors has been built for decades now, few decades, I would say, since the early 2000s. One of the other key areas is also automotive today, right? You see Indian car manufacturers like Tata, Mahindra is coming up with EVs, and that is also a very interesting landscape. And I have a lot of respect for them because I think today's products from them are, let's say, globally competitive. And it's still changing and still evolving. At the same time, I think we have investments coming from larger semiconductor players like Infineon, where they are setting up design center in Gujarat, very close to the manufacturing ecosystem, and so forth. So these are golden times, and I'm very bullish about how things are landscape is changing in India. But there are also areas where there's significant scope for startup ecosystem on the semiconductor side. Though it is a high investment arena, unlike software, but there is a lot of scope. But if anybody has any bright ideas, please do reach out to me. We can discuss and nurture. I'm also nurturing a few startups on the semiconductor side as a mentor. But I'll be glad to guide you building any business plan because I understand the landscape. But also having a good guide and mentor helps you also in the long run. So if you have a good product idea, let's discuss. But again, we're very interesting times is what I would say.
Okay, great. I hope this video is shared among our viewers. Viewers, please share because you don't know who need this guidance. Mr. Ganesan is open for startups to guide them. So share it. Probably some who is in need of proper guidance, that video might reach him. Okay, so we are done with our question. You had something very important to share. You shared it. So we are actually done with our today's session. Thank you very
Thank
much
you.
for we have a list of questions and you patiently answered them all and you completed it within it's
On time.
57
Yeah.
seconds. That's
Thank you.
the
Thanks for
time
having me
to
on this show.
because it proves that you are a product leader because you always work in tight time to market schedule. It proves that
Right. Right.
it's in your routine. You are programmed like that. Within time
Thanks.
you will finish
Thank you. And thanks to you for controlling the questions and answers also, right? So, yeah, the good questions, good insights.
I always
I
try
really
to
appreciate it.
ask those questions if I get a chance to meet you and I know you
Absolutely.
are the person who is knowledgeable in this sector. I have queries. I will ask the same question if I get to meet you. I
Sure.
try to ask those questions just to understand the field and allied things because you are knowledgeable person in one domain. So and I don't know much. So obviously I will try to understand something from you. So
Yeah, I
that way
don't
I
call
said the
myself an
questions.
expert, but I'll share what I know, and almost I'm also constantly learning. So life is a journey of learning. So I'm also always trying to learn something new. But yeah, glad to share what I've learned, and
Okay.
please feel free to
Okay.
reach out.
Okay. So we will conclude our today's session. Thank you, viewers, for watching up to this point. Don't forget to like, share, and subscribe, and always follow the Semiconductor Podcast. Here we celebrate technology and people who are enabling those technologies. So
Thank you.
thank you, and bye for today.
Thank you. Bye bye.